Hello students, welcome back to our class. We were dealing with the lesson atomic structure and chemical bonding. Now we will be discussing about some more characteristics from structure of atom, and in that we are going to discuss about valence electrons. So valence electrons are generally the electrons present in the outermost shell of an atom, that is its definition. For example, when we are saying sodium atom, so it has one valence electron because its atomic number is 11. So you will write it as 281. So 1 is the last shell, in which that means the third shell has one electron in it. So that is your valence shell or outermost shell. So here it is written in same manner that the outermost shell of an atom is called its valence shell, and the electrons present in the valence shell are known as valence electrons. So many examples, like hydrogen has only one electron in its valence shell, although its atomic number is itself 1 only, so definitely it's going to have one electron in the valence shell. Hence this. Similarly, carbon has 4 electrons in the valence shell because atomic number is 6, so you are going to write the configuration as 2, 4. And then the chemical properties of elements, they are decided by these valence electrons only, because these are the electrons that are going to participate in the bonding. These are the electrons which are being lost, gained or shared by a respective element who will have this property to show formation of bond, or you can say a reaction with any other atom. So they are the ones that take part in the chemical reactions. The elements with the same number of electrons in the valence shell, they show similar properties, and this is the characteristic found in the elements that belongs to the same group. So when we are saying group 1, they have one valence electron in their outermost shell, so they are going to have similar chemical properties. The group 1 elements include lithium, sodium, potassium, rubidium, cesium, francium. So all are going to have similar chemical behavior towards different reagents, except lithium in certain characteristics, because it is the first member of the group, and all the first members from each group, they are actually found out to be showing their unique behavior. And when we are saying like group 1 alkali metal examples, these were, right? So they are mostly metals and they show electrovalent bonding. But lithium has character of covalent bonding as well. So this is the unique nature they show. Those with different number of valence electron, they are going to have different chemical properties. Elements which have valence electrons 1, 2 or 3, except hydrogen, they are metals. These elements lose their electron to form ions, and which are positively charged, and hence they are called as cations. For example, see sodium. Sodium has neutral electronic configuration 281, sodium atom. So when it loses the one electron from it, it gets Na plus, where it has achieved now nearest noble gas configuration, that is neon configuration. An ion, on the other hand, if we define an ion itself, it is an electrically charged atom or group of atoms which is formed by loss or gain of electrons by a respective element. Elements will show different chemical properties because of the presence of different valence electrons, right? That is what written here. So by this we mean simply that they will be preferring loss or gain or sharing of electrons in different manner in respect to elements having different valence electrons. So that is why their chemical behavior changes. Valence electrons, this is a simple diagram for magnesium element. They are considered as good reducing agents. Elements with 4, 5, 6 or 7, they show electrons in their valence shell, then they are considered as non-metals. These elements, they can gain electrons to form ions which are negatively charged and are called anions. So similarly, for a non-metal, the representation is shown. Chlorine, for example, a non-metal, atomic number 17, has configuration 287. So when it gains this one electron, it achieves the nearest noble argon gas configuration, Cl minus, then it will become a negatively charged, and then they are known as anions. They are considered as good oxidizing agents. So this is the atomic orbital diagram for chlorine atom. Elements with the valence shell having 8 electrons and helium having 2 electrons, they are not expected to lose or gain. They do not show such behavior because they have stable outer electronic configuration. They do not take part in bond formation, so they are considered as chemically inactive and are called as inert gases or noble gases. Valency of an element is the combining capacity of a particular element with other elements. So this, when they share, lose or gain electrons, they are actually combining with other atoms, and that capacity with how many numbers of electrons taking part in a chemical bond formation, that constitutes the valency of an element, and it is equal to number of electrons that take part in the chemical reaction. Valency of element having 1, 2 or 3 respectively will have 1, 2 or 3 valence electrons only, while valency of elements with 4, 5, 6 and 7 valence electron is 4, 3, 2, 1. It keeps on increasing, and you calculate it by subtracting 8 with the valence electrons. Then you get the valency of the element, and this is basically for non-metals. For metals it is direct, that is the number of valence electrons is the only valency. So what is the reason for chemical activity of an atom? Why does it chemically react to lose, gain or share electrons? So atoms does this in order to become stable. Everything in the nature wants to become stable by releasing energy from it, by releasing that active component which causes them to be reactive or unstable. So they do so in order to become stable. Same is the case with the atom also. Atoms of all noble gases except helium, they have 8 electrons, they have their octet fulfilled. This arrangement is known as octet rule. This is the table representing for inert gases, helium, neon, argon, krypton, xenon, radon. They have 8 valence electrons except the helium which has duplet configuration, and still it is considered as stable. Among all the elements, only 6 inert gases, which are also known as noble or inert gases or rare gases, namely helium, neon, argon, krypton, xenon, radon, they are non-reactive. Rest are reactive, that is inert. They do not combine with the atoms to form molecules. Since their outermost shell is already filled, so their combining capacity or their valency becomes 0. Helium has 2 electrons, duplet configuration in the shell, that is K shell, first shell, and which can occupy a maximum of 2 electrons according to the 2n square rule that you have learnt in the Bohr structure model. So it is a stable element, even though the 8 electron rule doesn't apply in its case. Thus, the chemical activity of atom depends upon the number of electrons in the valence shell of its atom. Chemically active atoms have an incomplete octet, that is less than 8 electrons or less than 2 electrons in case of hydrogen in their valence shell. The valence electrons of atoms contribute to the formation of molecules. So when they lose, gain or share these electrons in order to become stable, and that shows their valency also, and they are doing so in order to become molecule. So why do atoms combine? Cosell and Lewis in 1916 independently put forward the octet theory of valency or the electronic theory of valency. The same concept that they want to become stable. So octet rule has been put forward. According to them, the rare gases have stable configuration, that we know very well. So the atoms of elements other than the inert gases, they combine in order to gain such nearest gas, inert gas configuration. They have incomplete valence shell and they tend to attain the stable configuration just like noble gases. Elements tend to combine with one another to attain a stable electron configuration of the nearest inert gas, that is 8 electron in the valence shell. This is known as octet rule. However, in the case of helium, valence shell has 2 electrons. This is known as duplet rule. This is achieved either by gaining, losing or sharing of electrons with other atoms or of same element or another element. So that is what I have already explained to you, that in just simply in order to become stable, they follow octet rule and they lose, share or gain electrons by doing so. The number of electrons gained, lost or shared to attain the octet in the outermost shell will give the combining capacity of the element, which is known as valency. So this is another aspect or definition for valency. As a result of this redistribution of electrons, a force of attraction develops between atoms, which binds them together to form molecules. This force is known as chemical bond. In simple terms, we can say a chemical bond is a force of attraction that holds the two atoms together. It is a type of electrostatic force of attraction or a dipole force of attraction or van der Waals force of attraction. So many examples for the definition of force is there depending on the type of element, but they all will result in a formation of chemical bond. The atoms will be held together by this chemical bond, and that is nothing but a force of attraction. The nature of force can be different. So, if we want to define a chemical bond, you may define it as the force of attraction between two atoms that binds them together as a unit. I have already explained this. So, the chemical combination of atoms involves redistribution of electrons so as to leave each atom with a stable configuration. Then the term isotopes. It is also one of the important terminology in chemistry that you need to know. It is noticed that two atoms of the same element, they contain the same number of protons, but they may differ in the number of neutron cases. However, electrons, protons, neutrons, they are arranged in the same way and they give the atoms identical chemical properties. So there are two atoms belonging to same element, same pattern of configuration protons they have, but they have different neutrons, and due to which they have, because of protons, chemical behavior is same, but they will be having certain other characteristics, like an element showing similar chemical property but possessing different mass is said to represent isotopy, and the varieties of the atoms are called isotopes. So those pairs of elements having same atomic number but different mass number are considered as isotopes. Isotopes may be defined thus: atoms of same element having same atomic number but different mass numbers. You need to remember this definition very well. Examples are given to you. Hydrogen, it has 3 isotopes having 1, 2 and 3 atomic masses respectively, and 1 is the atomic number, that is common, and it is the only isotope which has name also. First one having first mass is known as protium. The second mass containing, which is a heavy isotope of hydrogen, is known as deuterium, and the third isotope having third atomic mass is known as tritium. It's a radioactive isotope. Carbon is also example. It has 3 isotopes having 12, 13 and 14 atomic masses. Carbon 12 is basically used in the calculating the atomic masses of other elements. Carbon 13 is very rare in the percentage, and carbon 14 is used in radioactive dating in order to know the age of substances. Chlorine is again a isotope is an element having 2 isotopes having 35 and 37 masses. Oxygen is having 2 isotopes, 16 and 18 masses. Potassium is having 2 isotopes having 39 and 41 masses. In all the examples you can see the subscript represents the atomic number and which is same in all the pairs. Now we are going to discuss about structures of the isotopes. The hydrogen example first. So it has 3 isotopes, namely protium, deuterium, heavy hydrogen or tritium, each having same atomic number, that is 1, but different mass number 1, 2, 3 respectively. We have discussed this, right? So in other words, isotopes differ only in the number of neutrons. The protium has no neutron, deuterium has 1, whereas tritium has 2 neutrons. You can easily calculate it and you can easily see it in this figure also, that they have 1 proton plus 1 neutron and 1 proton plus 2 neutron in protium, deuterium and tritium respectively. These are represented as H, H and H, and where you will write it subscript 1 only in all, and superscript 1, 2 and 3 representing the masses. Okay, so how we are saying that they have different neutrons? So we know that atomic mass is equal to number of protons plus number of neutrons of an element. So if you want to calculate neutrons, you will subtract protons from the mass only. So first one having atomic mass 1, proton 1 has 0 neutrons. Second isotope having mass 1 but proton having mass 2 but proton 1 will have 1 neutron. And the third isotope tritium having mass 3 and 1 proton will have 2 neutrons. So from here you are calculating using this formula, nothing is there, right? This is a chart showing number of protons, electrons, atomic number, neutrons, mass number. So number of protons, electrons are same in all the elements because it is equal to number of protons only. Then carbon is atomic number having 6, has 3 isotopes, 12, 13 and 14 masses, right? They are represented by the symbols these. Okay, so you can easily calculate now for anyone. So let's calculate for 13. So we know that mass of 13 isotope is 13, right? And it has protons 6. So it has 7 neutrons. So that's how you calculate for any isotope, if you know the mass number and the number of protons. Chlorine, the two isotopes are 35 and 37, same atomic number 17. So we'll have same protons and electrons. However, they differ only with respect to number of neutrons contained in the respective shell, as having 18 and 20 neutrons. So what are the properties of isotopes? They will be having similar chemical properties because of the presence of similar electrons and protons. Isotopes have same atomic number, same number of electrons, protons, hence same configuration. Chemical properties determined by the electronic configuration of atom only, because it is the thing which is going to take part in chemical formation of chemical bond formation. Thus, isotopes and element are chemically alike, similar. For example, the chlorine atom of mass number 37, it undergoes the same reactions as the chlorine atom of mass 35. Same reaction, for example, reaction of chlorine with sodium. Chlorine is a diatomic gas only. So it is going to form NaCl only. Now this chlorine could be of 35 mass and 37 mass, but it is going to result in the formation of NaCl. It is going to have -1 valency only. So according to that, the formula would be generalized. Isotopes differ in few physical properties because of the difference in the masses, like density, boiling point, etc. Physical constants or physical properties, they depend on the atomic mass. And isotopes have different masses, so they will be having different number of neutrons, so definitely different physical properties. Like boiling point of protium is 20.38 Kelvin and that of deuterium is 23.5 Kelvin. So as the mass increases, you can understand the boiling point is increasing. Thus, the higher the mass of the isotope, the higher is the boiling point. Isotopes like tritium, carbon-14, it illustrates another difference in physical property, that it can occur between isotopes as they are radioactive also. The extra neutrons in their nuclei causes them to be unstable, so nuclei break up spontaneously, emitting certain types of radiations. Alpha, beta, gamma radiations are liberated, and thus carbon-14 and tritium, which is also a radioactive isotope, are radioisotopes. That tritium also generates energy. The spontaneous decay of unstable radioisotope is the phenomena known as radioactivity. Isotope of cobalt. Now we are going to discuss about uses of some specific isotopes of elements. Cobalt having this 27 atomic number and 76 is the mass. Okay, it is used in radiotherapy for treating cancer and other diseases. Carbon-14 is used for determining the age of historical and geological materials. An isotope of uranium-235 mass, 92 atomic number, is used as a fuel in nuclear reactors. An isotope of iodine having 53 atomic number and 131 mass is used in the treatment of goiter. Fractional atomic masses now. So after discussion of isotopes, there are certain elements which are considered to have fractional atomic masses, that is in decimal form. For example, chlorine, it has 35.5. Copper, it has 63.5 atomic mass, and so on. So there are various elements having fractional atomic masses. So an atom can have fractional atomic mass, like the example of chlorine. The reason is that atomic mass of an element represents the average weight of naturally occurring isotopes for that particular element. An element, because of presence in the form of isotopes having different masses, then those masses are taken as average in order to calculate the fractional atomic mass for a particular element. For example, this chlorine only, it has 75% of 37 atomic mass containing chlorine isotope and 25% of 35 atomic mass containing isotope. So these isotopes, these are in the ratio of 3:1 respectively. So thus, the average atomic mass of the chlorine is calculated as 35 into 3 and 37 into 1 upon 4 equals to 35.5. That is 35 written there, okay, not 37. Then there is another category, isobars. So like we have explained for isotopes, there is a just opposite difference for isobars. They are atoms of different elements with same mass number. So here mass is same but different atomic number is present. Since the properties of element depend upon atomic number, So they have both different physical and chemical properties. For example, argon and calcium. Here, argon has atomic number 18, calcium has atomic number 20, but their masses are same, that is 40. So because their atomic number is same and chemical behavior is because of the presence of electrons, so they are going to have different chemical and physical behavior. Second example, like chromium and iron, so they have 24 and 26 atomic number differently, but they have same masses 54. So with this we will wind up the session where we have covered part 4 of atomic structure and chemical bonding lesson. Now we are going to discuss about chemical bonding in our next session, that how these bonds are formed. Till now we have explained in today's session that what is a chemical bond and what is the necessity to form that chemical bond and what are the things that play role in the formation of chemical bond. Now we will be discussing types of chemical bonds, chemical bonding in detail in our next session. Till then, revise these topics. Thank you so much.